Hello everyone. Welcome to our session on integration of research software into the EOSC infrastructure based on the practices that we learn in computer science. So, let's begin with our introduction. I'm Mohammad Reza Saleh Sedpour, a third-year PhD student at Umeå University in north part of Sweden. And I'm mostly working on distributed system research and all computer science related stuffs. So, before move on to Sana, I want to just ask for your support for all Iranian peoples that are living in a horrible situation right now in Iran. And I would just to say, woman, life, freedom.
Yeah. Hi. I'm Sanna Isabel Ulfsparre. I work at Umeå University Library. And if you want to contact me after, you can have my information there as well.
Great. I think it's for you.
Yes. I will start with talking about what our basic assumptions and thoughts have been when preparing this presentation. We feel that research software in EOSC is important, and that EOSC infrastructure need to include research software more in order to fulfill the FAIR principles and also, of course, the FAIR4RS Software Principles that were released this year. It's important that EOSC infrastructure supports sharing, collaborating, evaluating, reproducing, reusing, and preserving software in order to fulfill these FAIR principles, since software is often important to understand what has actually been done with the data and to understand the analysis. And we would also like to suggest that EOSC infrastructure include research domain neutral core of standards for research software as well as for, say, metadata, as is already under work. And to establish a common ground, we would also like to start by talking a bit about transparency in research and research-related practices. Often now we are talking about transparency in the terms of repeatability and reusability, which is something we will return to, but I would like to take this moment also to remember that for qualitative research it is important to have the same transparency, but not maybe to reproduce the same research, but to show that conclusions and analyses are justifiable, to make it possible to discuss things such as unconscious biases and ethical issues, and to show a clear relationship between data, theory, and method, as well as rigor in the execution. However, since Mohammed has done the research that our presentation builds on, and he's active in computing science and distributed systems, we will mainly focus on reproducibility and repeatability in this presentation. So we would like to start by asking you, how do you define reproducibility? Please enter our Menti.
Yeah, you can simply just scan this code or open menti.com and enter that code, and you can simply just write anything you want and your opinion. So we'll wait a little bit so that everyone can write something for us.
Yeah.
And we can learn from you guys.
This is a check-in, since reproducibility is one of the recurring terms and one of the motivators between the sharing of data and open science. If you go to menti.com, yeah.
Oh, sorry. Just let me check. And here.
There we
sorry.
go.
Wait, here.
Oh, thanks.
Yeah, sorry.
About that.
We went to the last slide. It doesn't work? Okay,
I got it.
great.
Great.
Thanks.
Okay, now, yeah, it's also one topic.
Just a clarifying question. Are you talking about reproducibility for research or reproducibility for the software? Because in your introduction slide, you started off with terms relating to software
Yes.
and the sharing and whatnot for software. And I'm not sure this is still pertaining to software.
Yes, because actually the software that you are using in our research is specifically affecting our results. So that's why we define reproducibility in our thing that it might affect our research results. So
Okay, so this is reproducibility for
Yes.
the software,
yeah,
not for the research.
not for the research. It could be also for the research.
Yeah.
Yeah,
The thing is that you are active in a field where the software is the research.
yeah, it's the research. Yeah, exactly.
So
That's
I
the
would
point.
go for research reproducibility
Yeah.
here with the hypothesis angle.
Okay, so it's software reproducibility. Research.
Go for research reproducibility with the software in mind.
Yeah.
Yeah.
Okay.
And this is not just, it's not a thing to check if you guys have the right concept. It's just a way to check how you think about reproducibility, since that is a term that is so frequently used as a motivator for EOSC and open science. And this will tie into that.
Yes.
Maybe we can start showing the results.
Yes. Oh, not here. I have to go here.
So you define reproducibility as the research can be done again with the same methods and analysis.
Sorry, I have to move it here.
The ability to redo a process.
Yeah, it's
and then
just moving fast.
yeah.
Can you read them?
And produce a result congruent with the original one.
Yeah.
Same methods give the same results. The ability to verify something by repeating the original steps and checking and confronting the results.
Mm-hmm.
Yeah.
Yeah.
There is
Transparency.
a strong agreement here. Yeah.
Yeah, we have too
Transparency in method. That was a good point, I think.
many. That anyone can redo the experiment using the same software and data.
Yeah.
And maybe I have to.
Yes. Now that we have been thinking about this for a while,
Yeah.
do you want to give any more comments?
No, I think everything was really amazing.
Yeah, I think we're talking about the same thing.
Yeah.
That was the main point.
Yeah.
Should we go on to the next question?
Yes. Let me just go here.
Yeah. We, as our response to this question in this lecture, we have chosen a quote from, or a reference from Vitek and Calibera, a computer science article, saying that reproducibility is the procedure of independent confirmation of a scientific hypothesis by another team. So someone else should be able to understand it well enough to do it again and get the same results. We can go on to ask, how do you define repeatability? Now we are closing in on the software
Only software.
aspects.
So should we go to for
Yeah, we can go
responses?
for the responses. Oh,
Sorry,
back.
here.
Yeah, here we go. And I'll let you comment on this since
Yeah.
it's your field.
A characteristics of well-defined research outputs that when we run the they produce the same results. Yes. Ability to perform some steps again, even with different inputs. Nice. And reproduce a step-by-step process from a previous analysis. Yes, to achieve what, maybe, but it's really nice. Reappearance. Someone can go through the same steps to produce the same results. Yes. In terms of software, that's what we're talking about. And that the experiments can be repeated again and again, providing the same results. Again, the same. Ability of the researcher to repeat smoothly a part or the full research independently and having access to the same data, tools, and software. Yeah, to some extent, yes, it's complete answer.
Yeah.
I think we can also see our definition.
Yeah, we can go to the definition. So, the definition that we referenced the same article was that repeatability in software is the ability to rerun the exact same experiment with the same procedure or on the same or comparable system and receive the same or very similar results. That is that it should be predictable, I guess.
Yes.
Yeah.
Okay, so let's talk about my research, how we do research in this system. Based on my understanding at what I've learned during my research, we normally have some research question, and to answer those research questions, we try to develop some tools, some software. Maybe there are also some implemented software there, but we have to write some experiments for those software to configure them, to tune them, and those kind of stuffs. And when we are performing these experiments, we also monitor the data, gather the data, and finally we analyze this data to answer those research questions in the first step. In the first system, we normally we can consider that developing the tools and also the open source tools that they are already there, and also the experiments and data collection phase could be called as repeatability because everyone can repeat that cycle, and also the whole thing from research question to data analysis we can call it as reproducibility. But I guess we have a more important question for you. Sorry, here. I have to go here.
Yeah, back.
Yes, we have some answers there.
We need to ask you the question.
Yes.
So
Sorry.
back into the slide. What we wanted to ask you as a result of these definitions is, do you think that current research is repeatable and reproducible? Or do we need to extend our efforts?
I guess a different question.
Different.
Yeah.
Do you get a different question?
Yes, let me check.
I get this question.
Yeah, it's the correct.
Yeah,
the right
this is the question. Do you think that there is a reproducibility crisis?
Yeah.
Right.
The previous slide.
Right.
Yeah.
Yeah, sorry about that. Yeah.
Okay. I really like the answers.
Yeah, they are consistent with what we have
Yeah.
in our slides. So if
We
we go
shouldn't be
back,
happy about the result, but
we
actually,
shouldn't be happy, but it's a common problem formulation.
yes,
So if you could go back to our presentation.
yeah. So just let's calculate that 91%.
Yeah.
Great. So let's get back to our slides.
Yeah, the reason that we asked this question was that in 2016, Baker published in Science, writing that in a survey published in 2016, in this survey, 90% of the researchers answered that they thought it was a slight or significant reproducibility crisis. So you match them still from what is it, like 7 years later?
Yeah.
Yeah.
The same results.
Yeah, and even before that, this was an issue. So McNutt in Nature 2014 wrote that the scientific community was shaken by reports that a troubling proportion of peer-reviewed preclinical studies are not reproducible. And this can be traced even further back, and that is kind of a core issue since reproducibility is a core concept in quality for research. So our conclusion is that it's not enough to just support data sharing. EOSC also needs to support research software in order to support reproducibility, repeatability, and validation of qualitative processes. Because without the research software and without the quality control of the research software, it becomes really difficult to determine the quality of the research. So, and that's why we are looking to share
here
from the experience of the field where research software is the core.
Yeah.
And now we are going to dive into the lecture part of this presentation. And if you have any questions during, please continue to use the Menti. I will keep an eye on your questions here. And we will also have a Q&A opportunity at the end where you can ask verbally. So, to repeat what we said at the beginning, EOSC for research software, we need to be able to share, collaborate, evaluate, reproduce, repeat, and validate research, reuse the software as well as the data, and also there needs to be preservation of the software. There needs to be a long-term thinking of software. And we have illustrated this as this is a cycle that the infrastructure needs to support. The researchers who share, collaborate, evaluate, repeat, reproduce, and validate research and reuse them. But also reviewers of software review, where the reviewers can collaborate, evaluate, repeat, reproduce, and validate that the software is sound. And also, of course, the repositories and the publishers making it possible to share and preserve research software so that researchers can access it and use it again. And as a result of this process, there is descriptive metadata is generated that can also be used by, for example, funders and HEIs to evaluate on a higher level to evaluate the research output that is generated in the process. So when we think about infrastructures for the research practices, it's also important to remember that researchers are not the only ones looking at this. So the metadata that they generate might become the basis for future evaluations and future reward systems. Yes.
One thing I want to add is that with this cycle, if we repeat this cycle for various years, we do believe that the reproducibility of the research result could be somehow improved to some extent, because we believe that that is something happening in computer science right now. Maybe we could also generalize those practices to other fields.
Yes.
For software, mostly, research software.
Yes, and since these processes become more visible, the motivation for writing good software also would increase, probably. So, we are going to talk about integration of computer science, namely distributed systems, and how we can integrate the best practices from the field into a more generalized infrastructure. So we want to talk about generalization of existing practices for open source communities, infrastructures and features, evaluation and quality control and scholarly communications practices. And here it might be good to mention that in Mohammed's field, they mainly publish in conference formats. So many of the practices we will talk about comes from that context. Yes. But could probably also be generalized further.
Yes, I think from now on I have to talk a lot. Okay, so...
we have a question too. Maybe we should go for that one.
Do we have a question?
Many research require complex setups of the research environment, so reproducibility of the actual research is not enough. It should be experiment, automation, and orchestration. This is interesting.
We are going to
return
talk about
this.
that a lot. Actually, the whole presentation is about that. Okay, actually, for software that we are producing during our research, in 2011, Association for Computing Machinery, let's call it ACM, introduced a new badging system that they reward a badge for researchers who publish their software alongside their paper. And the whole reward system works in this model that, for instance, we publish a paper, we submit a paper in a conference, then we get the acceptance, and then they ask us if you have any software, submit it for software review, and then they reward the badges for us. They started it in 2011, and in 2015, we had about 8 submitted artifacts, and in 2021, we had 614 artifacts. Which somehow shows that it's going to be a trend in computer science. But let's take a look deeper. Because I'm mostly working in distributed system, here is the chart to somehow show that how many papers do we have in different years. And as you can see here, we have, for instance, the 614 papers for 2021 is shown by the green color, and the majority of that submitted artifacts belongs to conferences, and a minority for journals. And distributed system is doing great, I would say, for this artifact evaluation thing. And just one thing to somehow highlight, the reason that we are not publishing in journals is their huge review time. So this timeline that we extracted from conferences is based on a paper that we worked during my PhD studies, and it's in the review at some point. So how did we perform this study? Because I'm working in distributed systems, so here are the keywords, the most common keywords for distributed system. So we searched for these keywords in 4 different libraries: ACM Digital Library, IEEE Explorer, WikiCFP, and ResearchR, to find if there is any conference or any paper for these keywords that includes an artifact, or any conference that they have an artifact evaluation process. Because, as I mentioned, they had this artifact evaluation process for rewarding the badges. So, in general, we selected these conferences for the last 3 years to understand how did they perform this artifact evaluation, and what are the best practices. And we believe that for the last 3 years, they already discussed all the previous, they already learned from previous years. So that's why we just chose the last 3 years. So, just to somehow highlight what we did, we extract conferences in distributed system. Yes?
I think we're getting some feedback from the other mic on the podium. Can we?
Sorry?
Can we turn that off? Yeah.
How can I turn it off? Yeah, great.
Maybe we can just redirect
I can't find anything. Or maybe we should just move it here.
Yeah.
The best way. Okay, so in general, we extract conferences in the distributed system, and then we extract the conferences employing the artifact evaluation process for the research software, and then we extracted the guidelines from conferences' public website, and then we try to extract the best practices for different groups. For researchers who are trying to submit an artifact, submit their software to those conferences, reviewers, and for community, for funding agencies, repositories, policymakers, and publishers, HEIs, and also training and research support. So let's move for each one of these groups to see what are those best practices. Okay, so when we are going to submit a software, what kind of materials should we submit alongside that software? The first thing is an introduction. If someone else just read that software, that code, how should they understand what this code is going to do, and what this code is about, how it's related to the research? So there should be a brief, not a brief, I would say the really complete description about the whole software, and also let's call it an abstract somehow at some points. Also, because reviewers, when they are going to bid for this software, for reviewing this software, they are going to read this introduction. So it should be so complete.
Yes, and also if people who aren't reviewers but other researchers want to do something similar or use it, they should be able to understand what it is before actually employing it.
Yes. Sorry. Okay.
Software should be in an archival repository, so it gets a DOI. Persistent identifiers are important, as we all know.
Yes, because sharing research data such as artifact makes research more transparent and allows others to assess and re-evaluate the results.
Yes.
So that's why we should somehow export them or store them in archival repositories.
Yeah.
That those archival repositories such as Zenodo or those kind of things, or Figshare, can assign a DOI for that specific software. That's the best practices that the conferences are using.
Yes, and that would also make it possible to connect the research software with the data and the publications.
Yes. Let's go for algorithms. At some points in our studies, we may propose a new algorithm, and we have to, because especially when reviewers are reviewing, they have to read the paper carefully and understand what is happening inside that paper, and then go to review the whole software. So it's somehow, it could be really useful for the reviewer, for the sake of reviewers, to describe the algorithms so that the reviewers can understand what is happening inside that software and what kind of algorithm do we have there. So the algorithms should be described in the software, and then the next part is required resources. For each software, we may need a specific hardware or multiple hardwares, or we may also the time that we are going to run experiments. All of these things should be described in this section for required resources for in each software that we are submitting. And then each software could have different inputs, such as, for instance, a configuration file or a data set or those kind of things, or a model as well, if it's working with machine learning stuff. So these inputs should be described, and for instance, if they are not attached to the software, the procedure for retrieving them from outside, it should be described there. That we, for instance, we need this model can be downloaded from this URL. And then there are runtime states. About runtime states, a software, when we are running a software, it could have different, a specific state at the time that we are running that. And so this might cause that this software could be sensitive to runtime states, such as cold or hot cache, or contention in the cache or network. So this sensitivity should be analyzed if we are really specific in the software. So this sensitivity should be analyzed and should be reported so that the evaluators and other people who are trying to understand our software and they are going to repeat our experiments, they could somehow, understand that they need to do something before for these runtime states. The next thing that we understood in many conferences and many papers was that the reason for this problem dimension is that reviewers may want to read the whole paper to understand what this paper is trying to, what problem is this paper is trying to solve, and how many dimensions does this problem have. And the simple thing that we read in some papers was that they just draw a chart of problem dimensions. And it could really make the reviewers work really easy for reviewing the software, so that they can simply just track on the specific problem in the software for evaluation. Then the next part is metrics. Metrics are simply quantitative tools that we can evaluate software and evaluate the research data and the research results. So the metrics that we are using in our software should be described in the in our software, in our introduction, or I mean in the whole document that we are applying. Or
as a librarian, I would say in the catalog post.
Yeah, nice.
But in the metadata description of the software, we are now in the field of where we would describe a digital object in a way that it is possible to understand it, what it does and what is required of it, without entering into the source.
Yes. The next thing is planning. As I was telling the story that when the paper is accepted, then they ask for submitting the artifacts or submitting the software. Then the researchers have about 1 week to submit the artifact, and it's not possible to prepare the whole artifact in 1 week. So it should be planned. And also, I think in your Open Science, we have this data management plan. Maybe we should have something like data management plan for artifacts as well. For artifact management plans?
Yeah, artifacts.
Something like that.
In this case,
and
software and
it should be attached to the software.
So maybe the data management plans need to be developed towards also including the software aspects.
Yeah. Then the expected outputs. The expected outputs of each experiment or the result, the software should be described so that people who are repeating those experiments can understand if they're running those experiments correctly, they got their correct results, and also they somehow learn what they should expect from this software. Then the sample data. Sometimes the experiments that we are running in our research may take a huge time. For instance, in my previous research, the experiments took about a month, and it's not possible for reviewers to rerun those experiments for about a month because the whole evaluation period is 1 month. So sometimes they ask for some sample data or the whole data that we gathered. So if you remember the chart that we had, they asked us for the collected data. So maybe it could be a good idea to also attach those data to the software if the reviewers don't have time to repeat the whole experiments, so they can simply just perform the analysis part. And then the licenses. The most important thing for the community is the licenses, because then the community can understand how they can benefit by reusing this software or repeating the same experiments and those kind of stuff. So we should also provide the licenses for our software. Then the other thing that we already saw is that they ask for programs. For instance, some software may need other programs, for instance, some benchmarks or some libraries that when we are coding. So those things should be described alongside in our software, and also how we can retrieve them. The next part is the experiments. Experiments could be a manual steps. For instance, you have to run A, B, C to run the whole experiments. Or it could be an automated script. So these things should be also described in the software. And the most important thing is the source control. Source control or version control systems were originally developed for used by teams that are developing larger scale softwares for enterprises. But it seems that using those things for a small PhD projects also can help. So maybe it's really a good tool to somehow prevent some losses that we are in time that we are developing our software. These tools can somehow help us to prevent those losses.
Yes, and it also makes it possible to clearly connect the version of software used to the version of data used to increase the transparency.
Exactly. And the next thing is automation.
Yes, connecting to the answer to our Q&A.
Yes. And the whole automation or the CI, continuous integration, continuous development pipelines that we already have in software engineering, using those techniques for automating the whole thing from testing and from, for instance, deploying to the, for instance, the experiments, automation could really save a lot of time for researchers when they are developing their code. But the earliest step is really a nightmare, based on my experience.
We have another question.
Yes.
How important is it to freeze a reference with relation to dynamic referencing involving libraries, tools, etc.?
Let me just read it again. Freeze. Actually, it's quite important when you're publishing your software and versioning, and if you have a versioning system, this freezing thing could also, because maybe in version 1 you are using a specific version of some libraries, but when you're moving to another version, you're somehow updating that library or simply just removing that library, and instead you're using other libraries. So freezing that a reference could somehow help us in for different versions. That was a nice question. Okay. The other thing is test-driven developing. The most important part that authors somehow, they are not doing it right now, based on my experience as artifact evaluator in many conferences. They are not using test-driven development methods because it takes a lot of time. But actually, when, for instance, during the evaluation, when we ask, for instance, this is not working, change that, and they are trying to fix that issue, then they will lose some other part. They will break some other parts. So if they had some test-driven development method, then it could somehow help them to fix those things as well and detect those errors. And the most important thing is public cloud. Most of the time, especially in distributed system, we are using huge infrastructure. For instance, in my previous experiments paper, we used about 10 servers, not just the computers. Or I know that people are using more than 50 servers. So it may not be possible for everyone to have access to such infrastructure. So one thing that we always suggest to other people is to try to develop your software in a public cloud compatible mode. For instance, you can run your software in, for example, Google Drive, Google Cloud, or Amazon Cloud, or any other clouds. And I think we have a lot of things to do in EOS community about this one. Any comments?
I have comments on the next slide. So we can
yes, great. Okay, so if we want just to somehow break the whole thing, in the left part you can see that those things are somehow a metadata for our software, and the right part is the actual software, everything that and the methods somehow. And yes, I think it's your turn.
Yeah, when I see this as a librarian, I see basically an emerging metadata standard for software. These are the things that people need to know to understand and to reuse software, at least a core of it. And there are maybe probably even more factors as well. But when we look at the FAIR principles, for example, and the FAIR4RS principles also emphasize this, digital objects should be described with generous metadata. That is what it says. And generous metadata can be quite intimidating. It's kind of a large statement. So in order to make that possible, in order to make an infrastructure of it and build catalogs of it that can also communicate with each other, and our catalogs for data and our catalogs for publishings, such as articles and books, we need to move towards clearer definitions of what metadata do we need, what is useful in different stages of the research process. What is useful for reviewers and what is useful for other researchers. And as we're moving also towards an open science context where citizen science is a factor, we should also think about the open community aspects. So what can happen if we allow for test-driven developing where we foster a community where people help each other develop their software through these models, because that is also practices that are common in computer science and in computer fields that should possibly be evaluated and looked upon for other research fields as well. And these things are also important because not all researchers who write software are specialized in writing software. So these kind of information requests might also offer some guidance to what researchers might need to learn in order to write software that is sustainable over time and that is useful for others and possible to understand for other people as well.
Okay.
Yeah.
Until now we were talking about the best practices for researchers. Now let's move on for best practices for reviewers and the whole artifact evaluation committee in conferences. We had, in most of conferences, they are using the multi-stage reviewing for artifact evaluation. For instance, they had two-stage mostly. So it means that they review the software, and at one point they somehow get the first initial feedback that, for instance, this software is not working, try to do something more, and then they ask for other things for fixture, and then the authors fix that issue, and then again they review. And then after that it was the final thing. But for software it's not working in that way, because we have to do this evolution, this cycle a lot of times. So maybe we should have more than 2 times two-stage reviewing, maybe 10 stage, 10 times reviewing, or either more, for about the whole time slot for evaluation.
Yeah, and this could also be a way to support that community-driven development of software.
Yeah.
We have questions.
Yes. Okay. In which category? Okay, software environments. The software environments is the runtime states, as we talked about in that slides, and also software dependencies is the programs that we were talking about. And the next question, I think I should click on this.
Yeah.
Yes.
What existing metadata standards do you see as key to providing rich software descriptions? Well, I actually don't know the metadata standards for software. But I think that we should look at metadata standards existing for articles and data and make sure that there are connections. We need maybe a mic so that this can be recorded. Yeah, but I think it's recorded, so we need a mic so that they can hear you.
Okay, so I don't follow myself, but I've seen that Research Data Alliance has a couple of activities that related to FAIR software standards, FAIR metadata. Look there, and following your workshop or presentation, I will also look. But they are also touching this problem.
Absolutely.
But I'm not sure they are doing this from the software developers' perspective.
Yes, and that's very interesting. And I think the Research Data Alliance is very important. That was where the FAIR4RS principles were developed as well. We have another question in the back. Is it?
Thank you. It's not a question, it's a remark about an existing metadata standard and initiative called Code Meta. I won't develop further, but anyone can go look what it already encompasses.
Yeah, great shout out. So should we go back to the presentation?
Yes. Just one thing to add is that as a researcher that I worked in, I have some industrial experience. I had no idea about open science and FAIR principles and FAIR for research software. And the whole idea that came up to this presentation was just a chat between me and Sanna that I just understood that something is happening there, and I'm missing that. So I think that there should we have to somehow highlight these talks between different research groups and also invite them maybe.
Yeah, it also shows the power of communication.
Yeah.
Just meeting and talking.
Okay.
Yeah.
The other thing that we observe is that for the artifact evaluation committee, and also the chair of that artifact evaluation committee should provide the guidelines and checklists for both reviewers and authors to describe what are the criteria for evaluating the software. And because we have different badges in ACM badging system, but each one of them has different criteria. Those criteria should be described, and there should be a checklist for them. And that was one thing that we observed. The other thing is that it's also based on my experience as well. There should be a huge communication between different parts in artifact evaluation, especially between the reviewers and also the chairs should be somehow encourage that and facilitate that. There should be a platform there, which maybe we are missing today, or if there are any, I'm not familiar with, but I have experience in artifact evaluation, and I couldn't see anything as a platform for communication between reviewers and also the authors, which should be anonymous. And the reason that communication is really important, because sometimes when we are working on a specific topic, they may need a specific software, which not everyone is familiar with, and there is one more experienced reviewers, so the others can also ask some questions. That's why we need communication between reviewers. And also access to public cloud. We are talking about the software should be somehow compatible with working on public cloud like GCP and Google Cloud and Amazon Cloud. But the reviewers also should have access to those things so that they should have some credits for those things. Maybe EOSC can provide some connection between the public clouds, or if we have any research cloud in Europe, maybe we can use them as integration to EOSC.
Yeah.
Yep.
This might also be a way to support that innovation that I heard about in the earlier presentation of data spaces. The resources might be needed to be supplied, not only the data and the research software, but also the computational power.
Yes.
So,
I think these are for...
Yeah. Research communities. Research communities, we hope, will research and have discussions on best practices for software. And there should also be encouragement from research communities to engage in research software review. That should be seen as something that gives you something, that can teach you something, and a way to help each other grow. There should be more evaluation of new ideas and methods, such as maybe crowdsourcing and citizen science. What would happen, for example, if reviewers, there was also a shadow review board of people who are just really good at programming.
Yes, just one thing to add here is that we only have tested this method, this crowdsourcing method, once in computer science about 7 or 8 years ago, but there is no report about that. What was the result and how everything worked in that conference. But I think we can really work toward this one, and it could somehow facilitate the whole review of software, because it's a time-consuming task.
Yeah. And we also suggest there are interdisciplinary working groups for research software practices, because best practices might develop differently in different environments. We are presenting one of those environments now, but maybe there is someone sitting here or someone else in another research environment that has knowledge that would complement this. And there also need to be discussions about what is generalizable and what is domain specific, because some of the research software would be scripts or maybe smaller software. Do they need to go through the same procedures? Is this the best practice for those kind of software as well? Those discussions need to be had if we are going to have a general system where we have general contact points communicating.
Yes. And also one other thing is that we only have one working group right now, started about last year, again in ACM. I don't know what's happening in ACM, but we cannot see that in other domains. But and also they are working generally for reproducibility.
Yeah.
Yeah.
Oh, sorry. Research communities might also want to support and explore practices that follow the FAIR principles, and that is increased. That is facilitated now that these FAIR4 software principles have been released, because you don't have to look at the whole of it to get the gist of it. So that was that for research communities. And we also want to talk about policymakers, publishers, and funding agencies. We think that maybe FAIR research software practices should be embedded in policy and funding requirements in the way that other open science practices increasingly are. We also think that generous metadata describing software should be expected. We think that access to research software should be encouraged as open as possible and as restricted as necessary, as data is. And when it comes to research software, this might be a bit more complex as well, since there might be collaborations with private enterprises. There might be possibilities to commercialize software in another way. So even if we would go by the same slogan, we would probably recommend legal expertise to look at the specifics for research software. research on open science and practices for reproducibility should be supported and funded. So research on open science as such, we are going through a huge reform now that will shift the way that we do research in the future. Besides implementing the infrastructures for it, we should also research the consequences of those implementations more. And specifically for this lecture, we are talking about researching practices for reproducibility of software and what is needed to support that. And we also think there should be a badging system for software quality, and maybe a badging system, if we go generalizable, a general badging system that is controlled by an entity such as EOSC, so that there is an entity that is non-commercial that can guarantee transparency and that can also update with versions in a way that is transparent, so it can correct different misrepresentations. Because if we go for a badging system for research software, and research software becomes important in meritation and a reward system, then probably the badging system would be at the core of those evaluations. So it needs to be transparent and open. And lastly, we want to talk about training and research support, researcher support, because right now there might be a lot of researchers coding to do the research and analysis, but they do it for house needs. This sort of infrastructure would mean that the software would be spread openly, maybe a part of their meritation, that other researchers should be able to reuse it. It puts much higher standards on research software. Also that it should be functional, or should at least be described how it relates to other systems, so that it doesn't stop working because of a shift in an operating system, for example. And that it is clear also what building blocks need to be used in order to get the results. You want to go for this?
Yes. One thing about the clean code is that even me, as I have about 10 years experience in developing software, and when I'm reading my code for about 10 years ago, I cannot understand it. So that's what, and at that time, at that moment, I didn't know that there is something called clean code. And we do have best practices for clean code. And also we do have a book named Clean Code.
Yeah. Also development methods?
Yes, and also for if we are implementing something, we have different, we are not going to reinvent the wheel. We have some design patterns, we can reuse them. And also we have some automation tools. For instance, many softwares we do have, and they are free and available in open source community. And also we should also learn how to implement our code with a test-driven development method. And I think we need some training regarding this area, also for computer scientists and for other people as well.
Yes. Iterative thinking.
Yes, when we are doing test-driven development, each time we are fixing a bug and then we add something else, and it's a cycle. It's an evolution that is happening for, I would say, for a long time. We have softwares that are living for more than 20 years.
Yeah.
Any comments?
No. Use of infrastructure. I think also we need to have training in how to use these infrastructures, not just supply them, but also make it clear how to use them and the legal and security aspects of that. And also research software in open science and scholarly communications to make these connections clear. That research software is not like the hammer you put on the table and then you show the finished product. It is a part of the finished product, since it is essential in order to understand the whole. So how research software connects to open science and how it is or maybe can be in some fields integrated in scholarly communications. That is a field where we feel there might be a need for training and researcher support, and also legal training and support.
Yes.
Yeah.
I think the last part is really important because we were working on a project that there was software in Ericsson, the company in Sweden, and then we were trying to somehow add the license, and I think we had and also there was some negotiation between the Umeå University and Ericsson research company, and it took a long time, but because I have no idea about the whole legal and those issues in Europe, so maybe we have to also have some training for researchers to understand what is happening there.
Yeah, and also the support, because
Yeah, exactly.
the companies will argue for their benefits, and the researchers might need to have someone representing them who actually knows legal stuff.
Yeah.
Because otherwise there becomes an inequality in that dynamic.
Yes, especially when we are using open source software. Maybe they are open source, but we are not allowed to use them.
Yeah.
That's one fun thing.
Yeah, so these are our recommendations. This is our reference list, and thank you. Now we should go to the questions that have come in. Sorry? Yeah, here we go. This will, I moved over it since we will be sharing this presentation on the EOSC Symposium webpage, so you will be able to go and get them.
Yeah.
So I won't be reading them aloud. Sorry?
So you will publish this on the website in 1.5 months?
I think we have to ask Fila.
Yeah.
So after this session, as soon as possible, I will publish it.
Yeah. Yes. So now, thank you, and we should go to the Menti for the questions there, and maybe there will come more questions from the room. Yeah. What communities have you reviewed?
Actually, I was working in district system, and the only community that I worked for is district system. So, and distributed system research. Yeah.
Yeah.
No, I mean also ACM.
ITER. Yes. Actually, the main issue with other publishers, like for instance IEEE, they don't have such badging system. They try to add them, but for instance, you can add the code, but there is no review for that, and they don't provide any guidelines for that. So that's why we could only review the ACM conferences. And it might affect a lot because most of the time the artifact evaluation committee includes early stage researchers that are not really experienced in that topic. So, for instance, if a really well-known professor is publishing the software and a junior researcher, it might not really feel good, like the situation that we have for papers. At least a single blind is needed.
Yes, and you were suggesting that for this repeat review process as well.
Yeah.
Yeah.
Also, the communication between them should be anonymized. Also, I would suggest to have this, if it's possible, maybe if we could go for double blind, is I would say the utopia for reviewing softwares.
How open reproducibility can be achieved with commercial software?
The reproducibility with commercial software. The point with commercial software is that we are not allowed to share the results, share the software, but we can just discuss that we use this software, and here is the results. And if at some point we can provide the access to our software for reviewers for evaluation. But after publishing the software, we cannot reveal this access to this software, this commercial software. So that's one challenge that we have to deal with, really. But yeah, any comment from you, Sana, on this question?
No.
Yeah.
I think this is a legal question.
Yeah, I'm not really into legal. Yes?
You should and can always reference the exact version of the software.
Yes, exactly.
Doesn't mean that someone has access to it to reproduce it,
Yeah.
but in theory, you
Yeah.
can ensure that you can reproduce it if you get your hands on the software.
Yeah, but actually what we are trying to do in distributed system mostly is to work toward openness and try not to use this commercial software. They are really a headache.
Yeah, but I guess this is where the FAIR principle reasoning comes in as well, that it's the description, the metadata descriptions are super important, especially when you can't access the actual digital object. So you should be able to provide a generous metadata description even if you can't actually access the software, so at least you could have some more transparency into it.
Okay.
But I think it's also a legal question.
Yes. Okay, maybe we should go for next question.
Yeah. A RESA eScience Center event last week in Amsterdam has resulted in a draft declaration addressing primarily
Software
SWE,
funders?
software funders.
Yeah.
So it may be of interest regarding your recommendations.
Yes.
Great
That-
with these kind of shout-outs.
Yeah. That would be really great, I guess.
Yeah. Metrics and badging are risky in a complex scenario. Is there a way to help software providers reach higher maturity rather than evaluating their work with the risk of killing potentiality?
Yes. Actually, one thing that came to my mind is that is it possible to have the same thing for papers? If we can do that for papers, we can also do the same thing for softwares. But actually, we are not really able to publish the software because in my lab that we are working, if you just knock on the door and get the software, you are not able to rerun the experiments. While all of us are PhD students in the same department, we are computer scientists, we are distributed system scientists, and it's not really possible. So there should be an evaluation because there might be minor bugs that could be revealed and explored during evaluation. So I guess that we have to have these badgings, or maybe not badgings, but we have to have evaluations.
Maybe you can say something about how this badging system works as well, because it's quite, if I remember it correctly, it's quite focused on function.
Yes, yes, we have 4 different. Currently, we have 4 or 3 different badges. The first one is the availability. Everyone, if they just push their software into an archival repository, can get the one badge. But if it's functional, it's working without any error, but without producing the result, then they can get another badge. But if they can reproduce the result, they can get another badge. Yes, we have 3 badges.
Yeah. So it's directly connected to if you
Yes.
can run and use the software.
Yeah.
So
And that's why we suggested to have this describe this criteria for each badges.
yes, and that is also why I was thinking about the possibility of versioning a badging system,
Yeah.
because maybe once it becomes a given that badge A, making the software available, once everyone does that, maybe it's time to push another level.
Yeah.
So for me, this means that researchers would need to become professional software developers. Is that a realistic expectations? I don't think so. I think that researchers need to have more support in their software developing. I also want to give a shout out to the RSE people, the Nordic RSE, for example, who are researchers who have become interested, often researchers at least, who have become interested in developing software as they have worked as researchers and also want to maybe explore that as a career path for researchers to support other researchers in developing their software. So I don't really think, and they probably wouldn't think of themselves as software developers in the degree if you have read computer science.
Also, just want to highlight on an example. There is a tool developed by psychologists in University of Florida, I guess, and they implemented a virtual environment. It's a real and huge development task. And I would say if they follow the best practices that we describe here, these best practices could somehow make their life easier, because they are using that software for about 6 years right now. And I guess that some projects are they need software, so they can either choose if they want to make their life easier in terms of developing, or they can simply just not using those things. But it doesn't mean that they should be a professional software developers, because there's no end for software developers.
No, I would say more intentional in the software developing.
Yeah.
You were first. There need to be a mic.
Yeah, thanks.
So this was my question. I did not mean that they would think of themselves as software developers or would want to do a career change, but the best practices that you describe or we describe, the skill set effectively would make them professional software developers.
Yes.
And I can tell you from experience that even developers struggle with these best practices a lot of the times. So me personally, I don't see them being able to do this.
Exactly.
Or wanting to do this.
That's why we have to have this support and training from EOSC as an unbiased entity to support and train people for such environment for researchers, especially for research software.
Yes, and also a need for training at the HEIs. Maybe at the departments and the faculties. But I think also that maybe researchers do not need to go at it alone all the time. If there is a support system, maybe they can get that support also integrated in the coding. But I think there should be maybe an elevation of the basic knowledge of it. But then it's also this issue of the discussions in research communities and between research communities. Because if you write a simple script, maybe it's not relevant to describe the metrics needed in order to get the correct results. I think that such metadata should be adjusted depending on the need.
Yes. They should be optional if we are talking about if they are as they are described as metadata.
Yeah.
Okay, just to add to this comment, to this question, actually, it is very rare that researcher works only one, single. They have supporting from PhD students, master students who do the development, programming, but knowing what to provide in the published software is important. So another incentive that master students, PhD students gets credit for published data set and published software. So there is hierarchy. They participate in a joint publication, and lower, say, developers layers gets additional credits for software and for data sets. So this quite perfectly can be matched. But again, knowing this kind of even standard for metadata and for software publication is important, and even good to have templates for this.
The point is that currently the situation in ACM badging system is that when they write a paper and they also submit this software, ACM will add those badges on the paper with a link to the software. So actually, the software is not really separated from the paper. They are something, I would say, somehow connected together in a way. Also the researchers are highlighting, because they want to actually researchers want some credibility for their research. So they describe how to reach this software in their paper. So, but if they want other researchers to use their software, then it should be repeatable. And for instance, in my research, when I started working, I'm still using the software that I started developing from the first day of my PhD. And I'm still developing that software for about 3 years, something. And it's just adding every time.
Okay, and I want to add another aspect of reproducibility of experimental research. You are mostly talking about single publication, single research.
Yeah.
But look from the point of view of research infrastructure that actually designed and funded and developed for years to support multiple this research and publication.
Exactly.
So reproducibility, good practice, and good guidelines for research infrastructure, not for researchers, will be instrumental for researchers to do this more or less naturally.
Yeah.
So another angle from research infrastructure point of view.
Yes, that's a good point.
Yeah.
I think we have to consider it.
Yeah. Should we move on?
We can together.
Yes.
Yeah, come talk to us later.
We'll take it.
Here we go. What is the place of DevOps practices for researchers?
The best thing that I really love is DevOps. Actually, the whole automation thing is based on the DevOps practices, I would say. And those practices from DevOps could help researchers to develop better codes, and also make everything automated, and everything if they want to send the whole thing. Yes, exactly. And if they want to send it for running on public cloud, they can simply just run it with one click, and then that's done. So that's how DevOps can work.
Yeah. So no software should be rejected because it can be started.
Exactly.
Do you think TDD could be realistically asked to non-computer researcher as the code usually doesn't even have the tests?
At this time that we are talking right now, no, it's not realistic. But if we have some support from EOSC, that we have some training, then we could expect. Consider the situation, my situation. I have an amazing funder for my PhD studies. They just give me my salary, and they don't ask for anything, just an acknowledge in my paper. So, but what if they asked me for software? Consider that if we just started this situation in EOSC, and after 10 years we could ask a software with test-driven method, and also the whole code that should be working. So I guess in future it will be something realistic, but for now, no, it's not realistic. But at least we should have this for computer scientists, which we don't. Maybe I've seen about 10 artifacts out of 600.
Yeah, but I think this might also be one of those areas where domain matters.
Yeah.
The magnitude of the software
Exactly.
and the function of it.
Yeah. Actually, I would say that it's a never-ending area. It's always evolving.
Yeah. And for you, should there be an EOSC level source forge or the harvesting local forges?
Maybe we could have. Actually, EOSC should provide the infrastructure for, as we mentioned in that slide, I think it was, let me just go to that slide and show that maybe.
Yeah.
What we believe is that, how many slides do we have? I really like. Okay, so here. We believe that EOSC should provide an infrastructure that makes researchers able to share their codes. They could collaborate with each other easily, and they could evaluate their code, their softwares, if we have such evaluation procedures and badging system. And also, we can simply reproduce, repeat, and validate our results, and at the same time, we can reuse that. And maybe we could preserve this whole software for a longer time. I think EOSC could do that, because I've seen many areas in EOSC that they are, for instance, for preserving, I've seen some tools in EOSC. Any comments?
So would that replace a source repository? Or how do you see, because let's take GitHub as an example.
Yeah.
Let's say my code is there, I send you the link, I already shared the code. So
yes.
what else do you expect from, for example, sharing? What EOSC would do in that space?
Should I?
Yeah?
Yeah. I think that a key to EOSC is that it's a federated infrastructure. So if you have your code in GitHub, do you have a persistent identifier there? Do you have a metadata description? Because I think that your code in GitHub should be connected to the EOSC infrastructure or the catalog infrastructures through the descriptive metadata. So maybe you don't need to put your codes in several different places. You just need to have it where you have it and use clear versioning and then describe it in other places. And
also, maybe there should be an integration between GitHub and an EOSC platform. There could be. For instance, there is a direct integration between Zenodo and GitHub. That could be done. Yeah.
And very poor metadata.
Yeah. Yeah.
Yeah, but Zenodo is not providing any extra apart from me either sending you a Zenodo link, here is my code that is linked through a publication, or here is the URL to GitHub, which is the persistent identifier.
Yeah.
So that's why I was confused as in, okay, now it's going to be a standard European place where you can also go to.
The point is that if you just delete your repository in GitHub, then everyone loses that software. But if it's somehow, because Zenodo somehow download the whole thing, the whole version to Zenodo, and then they store it. If you delete your GitHub repository, then they still have it.
Okay.
That's the point. Yeah.
Yeah, and also one of the reasons that FAIR talks so much about descriptive metadata is digital objects can be huge and expensive to store. So if you can no longer keep that up, there should be something left, and that is the metadata description. So the generous metadata is important also to retain the knowledge in the system, even if the software goes away or can't be used anymore because progress has been made technologically.
Yeah, I'm an advocate that your metadata should be part of your source code.
Yeah, exactly, as a README file.
As a README file for dependencies, you have for separate languages, you have those conventions.
Yeah, exactly.
So a lot is already existing.
Yes, exactly. That's what we are suggesting. We can use them because we already have them. Maybe everyone can use them.
Yeah.
This is where it comes back to, as in how to educate researchers to start using that. That's the difficulty, in my opinion.
And if you copy-paste what you already have in your software files into the metadata descriptions, you make sure they stick around even if your software don't. So the last one in the Menti, crowdsourcing code review, like any SITSI, means you have to clean the data, estimate volunteer quality, and establish consensus. Are these well posed here enough here with the relation to methods to be made algorithmics?
Yes. If we consider if we are choosing our volunteers from an open source community, then it could be really easy. they can help us for code review. Not code review, that this software is actually working.
Yeah.
We are not looking for code review. We are not, the artifact evaluation committee is not responsible for code review. They are responsible to evaluate that if the software is working and if it's repeating the same results. In that sense, I would say that crowdsourcing could be an amazing thing. We can target, because we have many active open source projects, and we can invite the developers from that area, or because when I'm talking about crowdsourcing, it reminds me of that example that we had in computer science back in 2014, I guess. And they use social media for inviting people, and it really worked, actually. But I think handling that, managing the whole evaluation could be really tough. But if there is an infrastructure that can somehow help us, then we can ask for people who are interested and have some expertise in this area, then they can help us for code review. And if they cannot, they cannot.
Yeah.
We can't do anything about them.
And in general, I think it's important to remember that citizen science is a part of open science, and increased access for the public is a part of open science. But that doesn't mean that the public should do the same things that the scientists are doing. But that the public and citizen science and citizens' contributions can take other roles that might support or be complementary to internal science practices.
Yeah, one other thing that I want to highlight here is that open source community is working for more than 30 years, I would say. And they are doing really great. And I would say there is no device that you are having right now. All of them are having something from open source community. So I think that's the thing that could help us. We can learn from those experiences. And crowdsourcing, especially in open source community, could really help us.
Yeah. And with that, we're almost running out of time. We have 3 minutes left.
Yeah.
Is there any final question or comment?
Yes.
You mentioned two times about public clouds.
Yeah.
So if it will be public clouds has the free tier, most of them. And currently Amazon has a quite powerful free tier.
Yeah.
But if it will become as a part of business,
Mm-hmm.
because ACM charge money for.
Yeah.
So this may be something about tricky. And they may not allow ACM.
Actually, they are doing that. For instance, when I was reviewing for one conference, they gave me some credits for Google Cloud.
No, but still researchers,
Yeah.
if they use, for example, even free tier.
Yeah.
I don't know if I need to try to remember how we used. We used educational credits, indeed.
Yes.
We use grants.
Yeah.
But if the free tier or educational grant became publication business, I don't know how it will.
Actually, for that one, the educational grant that we can get for $1,000 to just check that if our software is compatible with public cloud, I think $1,000 is enough for most of cloud providers. So I don't think that we could run to funding issues.
No, not funding. The legal aspect of using open credits for giving money to publishers.
Yeah.
Okay, so whatever open source or not open source is a big business.
Yeah.
Yes.
And they earn huge money.
Actually, we are not storing any data on the public cloud. We are just using them as a computational resource for our experiments in my field. I don't, because it's against the regulation that we have in Sweden. I don't have to store anything on public cloud which is not in Sweden. which is not inside Europe.
But if you try to investigate this topic,
Yeah.
I would be very interested to know the result.
Yeah, exactly. I would say, because we had this discussion with our support for instance, for the GitHub, we are not allowed to store any research data or any research software in GitHub based on the regulations that we have in our university.
Yeah.
But then our university also provides us a GitLab infrastructure for us so that we can store our software there. I think that's one thing that the legal teams should really work on that.
And I think that this falls under the idea that EOSC is not just technical infrastructure but also legal infrastructure.
Yeah.
And we are not legal staff, so we can't answer this question directly. But if the engagement in these issues builds, I definitely think that the legal aspects of it need to be explored further so that EOS can support these things.
Yeah.
To make sure that it can support these things.
Yeah, one thing that I want to highlight is that this presentation that we had here was a utopia that I had in my mind that we could have in EOSC. And
maybe, hopefully, it can be useful and inspirational to something bigger now.
Yeah.
So thank you for listening to us and for staying all the way through.
Thank you.
And feel free to connect outside of this room and talk to us more.
Yeah.
So thank you.